Let me know if you are unable
yeah,
to solve.
Yeah, 1 minute. Yeah, it's like 59.
Yeah. Almost 60, right?
Yeah, almost 60. Yeah.
Very good. Very good.
Okay.
Now see, I'm going to start a new topic. That is azeotropic mixture. Azeotropic mixture. See, what is azeotropic mixture? First of all, there are some conditions and you can define the azeotropic mixture. Like azeotropic mixture are the one which has only two components. That means it must be binary solution.
Okay.
First condition is a mixture which has binary solution, and a mixture which is binary, that means one solute part and one solvent part. Then the second condition is that they must be in fixed composition. Must be in fixed composition. For azeotropic mixture, the composition of solute and solvent must be fixed. The third is after mixing them, their boiling point becomes constant. Constant boiling point. Due to which, do you know what is fractional distillation?
Yeah, it is a method of filtration.
Yeah.
I forgot how it happens.
Yeah. So see, this is the characteristics of azeotropic mixture. First, a mixture which has only two components and has a fixed composition and their boiling point become constant or same. That's why the fractional distillation is not possible. This type of mixture is called azeotropic mixture. Is that clear?
Okay. Yeah.
So there are some examples like if you are going to mix C2H5OH plus H2O, and C2H5OH should be 95% and H2O should be 5%, then this mixture becomes azeotropic mixture. That means their boiling point also becomes constant. That's why we cannot do fractional distillation of this. Is that clear?
Wait, what is fractional distillation? Can sir quickly
See, what is
explain?
fractional distillation? Just suppose we have a beaker like this, in which we have A and B is present. Okay.
Yeah.
And there is a connection, and there is a, and this is true. Just suppose A has 20 degrees centigrade boiling point and B has 30 degrees centigrade boiling point. Now you are going to heat it, then what will happen at 20 degrees centigrade? If you are going to heat it at 20 degrees
Yeah, A will
centigrade,
boil.
all the A will go and collect here.
Okay.
And in this
Okay.
way, you can, what we say, purify or
Yeah, filter.
extract
Yeah.
from each other this.
Yeah.
But if their boiling point become constant, both have same, then how will this work?
No, no, no.
No. So this is what I want to say. Okay.
Yeah.
Now there is another point, that is if you are going to mix HNO3 in water, this is you have this if this is 68% and this is 32%, then azeotropic mixture forms. If you are going to change the composition, it won't form. Okay.
Okay.
Can I change the slide?
Yeah, yeah.
Okay, it's very easy to understand, Davis. This azeotropic mixture or azeotropes, we can divide it into two parts. We can divide it into two parts. The first one is boiling point, minimum boiling point, sorry, minimum boiling point, and the second one is maximum boiling. You know what? The minimum boiling point will have that mixture which shows positive deviation, and maximum boiling point will have that mixture which shows negative deviation. Are you getting my point?
Okay. Okay.
Negative deviation is the one which has lower vapor pressure, and something which creates low vapor pressure, that means their boiling point will be higher.
Yeah.
You can connect with this negative deviation. What does this means? You know, this is the ideal solution, and negative deviation, you can see it is creating lower vapor pressure.
Yes, yes.
And if it is creating lower vapor pressure inversely proportional to boiling point. The one
Okay,
which
okay.
has lower vapor pressure will have higher boiling point. So
Yeah,
that's
yeah.
why maximum boiling point will be shown by negative deviation and minimum boiling point will be shown by positive deviation. Are you getting my point?
Okay, okay.
So if I am going to plot this, you can see this is the graph, and C2H5OH, it will, this is the graph, and this is the graph. So you can see this will be like this, and for this this will be like this. So if you are going to plot the boiling point, so boiling point, positive deviation, minimum boiling point, so boiling point decreases, boiling point decreases. I'm going to explain the mag. Oh, wait a minute, it's not working. And here the boiling point increases.
Okay.
See, if you have, this is your alcohol, this is your water. Just suppose this is your what we say C2 H2O, vapor pressure H2O, and this is your alcohol C2H5OH. As you know that C2H5OH has more vapor pressure than H2O, but in positive deviation, it what we call, it lowers its boiling point lesser than the one which is very low. Are you getting my point? This is your 352 Kelvin
Okay.
boiling point for C2H5OH, and this is your 373 Kelvin boiling point for water. So
Okay.
after combining, making a azeotropic mixture, the solution have a boiling point lower than 352 Kelvin. Is that clear?
Yeah, yeah. Yeah.
In the same way, here the maximum boiling point, that means it will be higher. Can I
Okay.
change the slide?
Yeah, yeah. Yes.
Okay. So it's very easy to understand. I'm going to give you a new topic, that is Van Hoff factor. So I'm going to write a small point and then write a mathematical equation. Then we will explain, see what is it. So basically it is defined as, should I write directly the formula?
Yeah, yeah, okay, yes.
Vector factor is denoted by I, and I is equal to basically number of solute particles, number of solute particles after dissociation or association. After dissociation, either dissociation or association upon number of solute particles before association or dissociation. Just I'm going to take an example. There is NaCl, there is NaCl, and initially you can you know that this is Na plus and this is Cl minus. Initially, before the start of the reaction, this is T equals to 0. So what is the mole of this? This is 1 mole, yes or no?
Yeah.
And this is T equals to 0. At T equals to 0, this is 0 0. But
Wait, what
after
is
some time,
T here?
this is 0 and this is 1 and 1. So if you are going to calculate the value of I will be equal to, after dissociation, 1 plus 1, it is 2, and before dissociation, 1. So I has a value that will be equal to 2. Are you getting my point?
Okay, okay. Yeah, yeah.
Always remember that for dissociation or in case of dissociation, I will be always greater than 1.
Okay.
Okay. And if in case of this association, I'm going to talk about in case of association. This is your association part, like CH3, COOH. You are going to take 2 mole of this, and what will happen here? It's very easy to understand. This is C double bond O, and this is OH, and again this is, and this is OH, and they associate with the help of hydrogen bond. And you can see initially it is 2 mole, and finally it becomes 1 mole. So this is a
Okay.
perfect example of association. And if you are going to calculate the value of I will be equal to, after association, since association takes place, so 1 by, got it?
Yeah, yeah.
Can I change the slide?
Yes.
Now calculate the value of I. The equation must be balanced.
Okay.
You can dissociate on its own, on your own.
Yeah, yeah. I equal to 1 for the first one.
I is equal to 1.
I no, sorry, not 1, 3, 3, 3.
3.
Yeah,
So you are going to balance it, make it balance first,
yeah,
balance it. Then after dissociation, it is 3, and before dissociation, it is 1, right?
yeah, yeah.
I is equal to, then,
Yeah,
and
I
I
equal
is
to
equal
4
to,
here.
then.
For B, it's
I is equal to, there, you are going to balance it 4 by 1, right?
yeah, 4 by 1.
Then,
Yeah, this one I got 5.
yeah, that's good.
Okay.
Now, can you tell me about this HC double OH?
Okay. Yeah, I guess it's one for this.
See, this is the organic acid, methanoic acid, and it will basically associate in the same way that we did the previous one. So you can see there will be hydrogen bonding. After association, it becomes 1 mole. Before association, it was 2. So in
Oh,
case of association, the value of Van Hoff factor is lesser than 1. And in case of dissociation, the value of Van Hoff factor is always greater than 1. Greater than 1. Okay.
yeah.
Van Hoff factor we can also define as, you can see that this is our CH3 C double OH. Okay, 2
Yeah.
mole. And if you are going to see what will happen, association will take place, and there will be like this, and then this. Wait a minute, it's hanging. Okay, it's okay. CH3, and now again you can see this is C double bond O, and then O, and then H, and then there is CH3. Now you can that there will be hydrogen bonding.
Yeah.
So I is equal to okay. If I'm going to ask you what is the molar mass of this, can you write the molar mass of this?
Okay. Okay. Wait. Mm, yeah. 60. Right.
60.
Yeah.
Can you calculate the molar mass of this?
Yeah. If it'll obviously be double, like 120. Right.
It's 120 because we always calculate molar mass for 1 mole. So it's 60, it's
Yeah.
120. And if I'm going to ask you I, that will be equal to 1 by 2, right?
Yes. Yes.
There is another form of I, that is normal molar mass upon abnormal molar mass, upon abnormal molar mass.
Oh. Okay.
So
Yeah.
basic abnormal molar mass. Basically, if you are going to do experiment and you took 2 moles of this CH3COOH, which has a molar mass 60, and you are going to do something that means react, and what you will expect? You will expect the mass, molar mass will be same, yes or no?
Yeah. Yeah.
So this, after association, whatever is the mass will be treated as abnormal molar mass, and this is the normal molar mass that you have seen. So it will be 60 upon 120, which will have a value 1 by 2. So I can be also expressed in terms of molar mass. I is equal to normal molar mass upon abnormal molar mass. Is that clear?
Okay. Yeah. Yeah. Clear.
Normal molar mass of benzoic acid is 122 gram per mole, and abnormal molar mass of benzoic acid is 244. Calculate. It's very easy.
Yeah, it's 1/2, right?
1/2, right?
Yeah, yeah.
Now see another form of this pi, that means Van't factor, which is observed colligative property, CP for colligative property upon calculated colligative property. First of all, I would like to remind you some formulas of colligative properties, that is zeta B is equal to P naught minus PS, that is pressure of solution, upon P naught. Okay.
Okay.
And then comes delta TB, that is equal to KB into M. And then there is another formula, delta TF, that is equal to KF into M. And then again another formula, that is pi equals to MRT, or in some books it has been written as CRT. C or M are same, that is basically your concentration, right?
Yeah.
So if I'm going to write now see this formula, which is very important. I is equal to observed colligative property upon calculated colligative property. So observed colligative property will be equal to I into calculated colligative property. Calculated colligative property. So I am going to just modify it. If I'm going to talk about delta TB, it will be equal to I into KB into M. Now, when I'm talking about delta TF, it will be equal to I into KF into M.
Oh,
And if we are going to talk about pi, that will be equal to I into M into R into T. If we are going to talk about this P naught A, P naught A, we can say P naught A also, if you want to say. P naught A minus PS upon P naught A, original pressure, will be equal to I into mole fraction of B solute. So whenever you are going to apply the formula of this colligative property, write I also. This is Van't factor. According to the question, the value changes. If
okay.
you will have something that will be dissociated, it will increase. If you will have something that will associated, it will decrease. And since I increases, decreases, the value also increases and decreases. Are you getting my
Okay.
point?
Yeah, yeah.
Now, whatever in the initial when we had completed our colligative property, the question, if you are going to see, I took the substance which is neither associate nor dissociates. That's why that was all okay. But
Yeah.
now if you will be given question, maybe the substance that is given in the question will be associated or dissociated.
Yeah,
So
yeah.
be careful of that. Okay.
Yes, yes.
Okay, should I change the slide?
Yeah, yeah. Yes.
Wait a minute. At 25 degrees centigrade, the highest osmotic pressure. The chapter is completed.
Okay.
This is the first chapter, right? We had completed.
No, no. We also did
Second chapter.
yeah, second chapter we did, yes. Yeah, first was solid state.
Okay. Now we need to do some planning so that we can cover in less time.
Yeah,
Okay.
yeah. I forgot about like making those
Okay, we
chapters.
will talk about today
Yeah, yeah, yeah.
logos, urea. Are you doing practice of questions
Yes, yes, I am doing, but
Because if you won't do it, you won't, there won't be much effect on your study. Like questions is very important for competitive exams.
yeah, yeah.
Writing your questions you need to do.
So what is the glucose is? I have to like find their I value.
Now wait a minute. I'm not able to hear you because uh, so noisy here. Can you repeat
Okay.
it again? What is the answer?
No, no, no. I'm asking like I'm supposed to find the value of I and compare.
Yeah, yeah. See, if you're going to calculate the value of pi,
Yeah.
that means osmotic pressure, you know that pi is equal to I into m into r into t.
Yes.
Now, if you can see, all will have same molarity since it is given
Yeah.
exhibited by 0.1 m of solution. All will have same this, yes or
Yes.
no?
Yes. Yes.
And all will have same
Yeah.
r is constant and temperature is also same.
Yeah.
So on which factor it will vary on this factor?
I. Yeah.
Are you getting my point?
Yeah.
Glucose neither associate nor dissociate. Not CaCl2 will have I that is equal to 3 and this will have I that is equal to 2. So which will exhibit the highest osmotic pressure,
CaCl2. Yeah.
isn't it?
Okay. Yeah. Yeah.
It's very
Wait.
easy.
So why glucose like will not dissociate or associate?
Wait a minute, I'm sorry. Can you repeat it again?
Yeah. Yeah. Why glucose will not like dissociate or associate?
Okay. Basically, for dissociation or association, do you know what the structure of glucose
No.
or
No.
urea? There
Structure.
are some factors like if you can see, uh, if you have studied this HOH, OHH, the structure of glucose, HOH, like this.
Oh.
So
Okay.
there is no bond between, basically they are not nearer between double bond O and H so that they can make bond
Okay.
form
Okay.
together. Like in case of we took HCOOH 2 moles, and if they are nearby each other, they can form hydrogen bond.
Yeah. Yeah. Yes.
That's why.
Okay.
Okay, wait a minute. So I was okay. I will ask you after some time. Okay. Now the next question: which of the following salts has the same value of I as that of K3 Fe CN whole 6? Option is Na2SO4, AlNO3 whole thrice, Al2SO4 whole thrice, and D is NSE. Please give it an attempt, then let me know.
Okay. Okay. Yeah, is it B option?
What is the answer?
B.
A, B, C.
B option.
Is it B?
Yeah, I got I as 4 and
Yes. See, first of all, we are going to dissociate this. If you
yeah.
are going to dissociate it, it will be 3k plus the components present in a square bracket cannot be dissociated. This is the rule for complex compound. So 3
Okay.
mole here and 1 mole here. So I will have a value 4. And if you are going to check for this, I will have a value 3. If
3,
you
yeah.
are going to check for this, I will have a value 5. If you are going to check for this, I will have a value 2. And if you are will have a value 4. So the answer is B.
Okay.
Okay.
Yeah.
So it's very easy, I think, right?
Yeah.
Now, wait a minute. I'm just scrolling down to a question.
Yeah.
So, can you tell me which topic is a strong? Like, we will talk about it after this question. Just
Fine.
wanted.
Yeah, B option.
Is it B option?
Yeah, yeah,
Very good. So
okay,
see, you need to make a like in this in the next chapter, that is chemical kinetics.
yeah,
You can see I'm just going to write the topic, the rate, and
yeah,
then the rate of reaction, that is basically, and then rate law, and then order of reaction, and then molecularity, and then after molecularity we have integrated rate equation, that is of zero order and first order. Then factors affecting rate, constant factors affecting, then temperature dependence, like this, temperature dependence. Like we have this much topic almost. There is more topic like RDS equation and all. So
yeah,
just let me know which topic I should lead. That you already know. That part is strong.
okay, okay,
Yeah. So this is just a demo. You are going to just uh, you can do this like write the name of the chapter
yeah,
and the topics you have covered on your own. Are you getting my point?
okay,
Because we have very less time and we need to cover 11th and 12th as well.
okay, okay,
So whatever is the chapter, whatever is the topic you are completed with, write the name of the chapter. First, you are going to do with this first book of class 12. Okay,
first book of
class 12.
class 12,
Like
okay, okay,
we have done solid state. So you
yeah,
are
yeah,
going to start with the chemical kinetics
okay, okay,
and then your electrochemistry. First, we will do chemical kinetics and then
yeah,
surface chemistry and then like this. Are you getting my point?
okay, okay,
So you need to do this. So
yeah, yeah,
it's very important. As soon as just let me do this. Just do that, please,
yeah, yeah, I will do as soon as possible, yeah,
and send it to Learnivio's WhatsApp. I will get that from there.
yes, yes,
Okay.
okay,
Okay. Wait a minute. Just quick. The freezing point. Last question of this class. The
okay,
freezing point. Depression constant for water is minus 1.86 degrees centigrade per molality. If 5 gram Na2SO4 is dissolved in 45 gram H2O, the freezing point is changed by minus 3.82 degrees centigrade. Calculate Van Hoff factor. So Davis take it as homo